Okay, I'm going to give you a very brief overview of what I will be doing for my PhD project. I will be trying to look at biodiversity during one of the key events in the history of life on Earth, which is terrestrialisation. And we probably all know that this happened during the Paleozoic, which is a significantly long time ago. We're going to start at the bottom of the food chain. We know that it happened in land plants, and then a little further on we see gymnosperms, which are the seeded plants, they come along. And then, of course, in the invertebrates, after the Cambrian explosion, you see insects starting to appear, but the groups that we're most familiar with today, like Hymenoptera, Lepidoptera, don't appear until the end of the Permian, with wind insects appearing in the middle of the Devonian. And then my group, I'm focusing on vertebrates. These tetrapods, early tetrapods, evolved from their fishy ancestors, if you want to use that word, during the Devonian, and then into the Carboniferous they began to diversify, and we get a whole explosion of different morphologies and lifestyles. And as this is happening, there was also a background of huge environmental transitions, and we see that the three of the main big five extinction events appear in the Paleozoic, so the end Ordovician, late Devonian, and of course the end Permian. There was also this environmental transition at the end of the Carboniferous, where we see a huge rainforest collapse. This has been looked at before, and it has been thought to be one of the largest implications in this huge diversification of tetrapods that we get in the Carboniferous. So this is not the first time that tetrapod diversity has been looked at. It has been looked at by a number of people before, but traditionally diversity analyses are done using raw data, and we all know that the fossil record is not absolutely perfect. There are a number of sampling biases, and obviously before even humans get to it, you have biological factors, so between different habitats you'll have different numbers of animals, you also have differences in evolutionary rates, and then as you get on into geology you have differences in preservation potential, and then once humans get into it, where they sample, what is sampled, what is available to be sampled, and this all affects your final sampling estimate. John went a good way in describing exactly how we can go and correct for this. There are different numbers of approaches, so you can use phylogenetic approaches, residual approaches, and we're going to be using for the first time our tetrapod data. We're going to use subsampling methods, and we're going to focus on SQS. At the moment, this is how my data looks. So we're using the Paleobiology database, and we've currently almost finished Carboniferous data, so you can almost say it's 100% complete. You might see some key pieces here up in Greenland. You'll see Acanthostega's location and where Ichthyostega was found. And then obviously the Karoo Basin down the south of Africa, so quite a few famous places already in the database, which is phenomenal. We have a bit to do in the Permian. If you ask any of our lab group, it's been a bit of a pain. But it's some work anyway we have to do. At the end of this, when all the data is collated, we will be able to answer a few key questions. Of course, we will look at biodiversity, how this goes up through where tetrapods first appeared, right up into the Permian, and then hopefully time allowing right up into the Jurassic. And then we'll also look at how tetrapod ecosystems responded to environmental transitions. So we'll hopefully be able to map our data to plant data and maybe even insect data. And obviously what is the main point of my project is to look at sampling and how that impacts the tetrapod data and the diversity estimate that we get, and to what extent these biases might limit our ability to do that. Thank you.